Hi, my name is Martinez. On our YouTube channel we had some questions about how to operate the MCDU on the A320 aircraft. So today I will show you the basic steps required to complete the pre-flight phase. So let's begin.
So here we have the standard multi-purpose control display unit as on A320-200 type aircraft. The main parts of which are the display, the line select keys, page keys, and alphanumeric keys, numbers and letters for data input into the unit. We also have here the bright and dim dial, which is used to bright and dim the display essentially. So the first thing we do when we come aboard the aircraft is do the pre-flight procedures, and when we have the power connected to the aircraft or the EPU on, we can turn on the MCDU. That means that turn the bright dial or push the button if the button mode is installed. The first page displayed on the MCDU is the aircraft status page. On this page we can see the aircraft model. This is the A320-200 aircraft. We can see the engine model CFM56. We can see the active navigational database, which is valid from 10th March to 7th April. And we can also see and select the second database, which is essentially an older database if we would like to use that. We also on this page can select the performance factor if we know it and is available. It depends on the aircraft getting, for example, older, and its performance factor is being modified by the maintenance and by the dispatch. After checking all these parameters and also the aircraft number, which is quite important because it has happened before that the crew simply went to the wrong aircraft. So the second page we go to is the initialization page. So on this page we have the following items: the company route, where we can enter the previously prepared route by the dispatch, or the historical route, which will automatically input the flight plan so we don't have to, the alternative route for other alternative airport, the flight number, which is quite important because this displays to the dispatch which flight we're flying, and the information will be given according to it. Also the latitude and longitude of the current position, the cost index as given by the dispatch, cruise flight level and temperature, tropo altitude from two airports and alternative airport. The tropo altitude is quite interesting, is the altitude at which the temperature gets higher as it increases. As you probably know, as altitude increases the air gets colder, but at this altitude it starts to get warmer again. The first thing we have to do on this page is enter the company route or the from and to points. If the company route is not available, then simply the departure airport and arrival airport is inputted into the MCDU. This is done via the keys. So for this example flight, we'll be doing a departure from Brussels airport, which is Echo Bravo Bravo Romeo, and we'll be going to Frankfurt airport, which is Echo Delta Delta Foxtrot, and we'll simply click the line key next to the value. This page shows the available flight plans between the two airports, the destination and the arrival airport. As we currently see, there are none, so we simply return to the last page. By continuing, we enter the cost index. The cost index is decided by the dispatch. It is usually around 35 to 50, but it can go from 1 to 999. We also enter the planned cruise flight level, which is 300, 30,000 feet, and the planned temperature at the flight level 300 is minus 44 degrees. We also enter the alternative airport, which is, according to the dispatch given flight plan, is Köln airport, and it is Echo Delta Delta Kilo. On this page, also as previously, we can see the proposed flight plans between these two airports. As we see, we have none, and the error here, the check database cycle, shows us that our database can be out of date and we should check it. We can clear the error by clicking the clear key. We return to the previous page, and the initial A page, the first page, is now completed. After the completion of the first init page, we go to the flight plan page. If you would have completed the company route and entered it in the previous page, this would show the complete flight plan. Now we only have the departure and destination airports in the flight plan, so we need to enter some more waypoints. The information shown here is quite simple. We can see the airports Brussels and Frankfurt here. We can see the time, which is on destination is not available, and on departure is currently 0. We can see the speed and altitude restrictions on the waypoints, and we can also see that we have a flight plan discontinuity, so we are missing some route part, and also that this is the end of the flight plan. So to quicker enter some waypoints, especially departure and arrival, the MCDU has special modes which we can access by clicking next to the destination and departure airports. So we'll start by departure. Here we can select the departure route from the airport. We select departure, and then it shows us available runways to depart from, 02, 07 left, and so on. We can also see their length, and we can also see the ILS designator and the ILS frequency. So for today we'll use 07 right departure, and we also have a standard instrument departure given by the ATC, which today will be this one. So we now see that we have selected the 07 right runway, the departure route is selected, and we have no transitions. This shows us engine out departure, which is sometimes available, especially in mountainous airports. We click either erase if we selected incorrectly, or insert to insert it in the flight plan. So we click insert. As you see, the flight plan page is a bit different now. We have more waypoints. The first waypoint is the altitude at which we will have to turn, and the last SID waypoint. For arrival, we also have it available from the dispatch. It is planned ahead of time. We select the destination airport. We select arrival. The arrival runway we plan for 07 right, and the standard arrival procedure will be Kira 1 Mike. Here you can see the transition. For this time it will be Tango Alpha Uniform, and we click insert. We enter the arrival and departure information into the MCDU, and we have almost the full flight plan because the destination departure airports are near each other. As you can see, the flight plan doesn't fit into the screen now, so we have the slew keys, the up and down keys, to go up or down and see the whole plan. So we have from the start Brussels 07 right departure and the SID then flight plan discontinuity, which we can erase by clicking the clear key I showed before. So clear and flight plan discontinuity, and we check that we would have all the waypoints right to arrival. On the right you can see the altitude restrictions automatically inputted with the star information. So this can be speed and altitude information. This shows us the bright red one, shows us that we have to be 5,000 or above 4,000 and above at this waypoint. It also shows us distance from one waypoint to another and the planned course or track 068 on the arrival. After entering the flight plan, we go to radio navigation page and check the navigational information entered by the MCDU. So we have the Bruno VOR available at frequency 110.6, and this is correct. The second VOR will also be the same frequency, we enter the course we want to follow to the VOR. Let's say in this case it will be 255. We can also insert additional information like ILS designator and frequency, also ILS's course, and ADF 1 and 2 designator and frequency. If the ADF is available or all other designators, for example VOR or ILS, are available in the database, the frequency will be entered automatically. If not, then we can enter it manually. This is essentially all we have to do in the radio navigation page. After completing the radio navigation page, we return to init page, which is called init page A, and we go to init page B with the next page button. In init B page, we enter the fuel weight and also the zero fuel weight. That means that the weight of the aircraft without the fuel, which is already entered and is currently given by the dispatch as 52.4. We can see it here. And we also have the zero fuel weight center of gravity. This is measured in percents and it is given by the dispatch as 29.6, and then here. What we have to do now is enter the fuel amount that we take on this flight. On this flight we will need 5.2 tons of fuel. We enter 5.2 and enter next to the block fuel. After a few seconds, the aircraft has calculated the times and the fuel use for this flight. So we have the taxi time, which is 20 minutes. We have the planned trip time of 56 minutes, and we are planning to use 2.4 tons of fuel for that. We have the reserve fuel at 5%. Time to alternative airport is 15 minutes, and additional time for any malfunctions or other things like that is 30 minutes or 1 ton, and extra time 22 minutes. So all in all, we have the takeoff weight, the full weight of the aircraft before takeoff is 57.4 tons, and the planned landing weight is, if everything is okay and we'll use the amount we are planning for, will be 55 tons. It is very important to complete this page before engine start, because after engine start we won't be able to change any values, and this page will automatically change to fuel prediction page. After completion of init B page, we go to performance. Here we can see the speeds for takeoff, V1, VR and V2 speeds. We can see the transition altitude as given by the database. We can change it if we wish, if the ATC gives another or the charts indicate otherwise. We also have the thrust reduction and acceleration altitude, which is now in default value of 1680, both the reduction and acceleration. We have the planned runway 07 right. We have the takeoff shift. Takeoff shift is if we don't have a full runway for takeoff, if for example there are works or the runway is being under maintenance, and for example if we don't have 3000 meters but we have 2500 meters available for takeoff, we'll enter 500 to compensate for this. This is for reference. We also enter the flaps and trim horizontal stabilizer value. Flaps usually entered are 2 or 1 plus F. The standard is 2, so we click 2 and enter flaps. We can also enter trim and horizontal stabilizer, which has values of up or down and the number. So in this case we enter that we'll have flaps 2 and the trim will be up with a value of 0.5. We also have flex takeoff temperature. If we don't have high altitude or high temperatures, we can save the engines and do not take off on full power, but compensate for it and have a lower thrust value. So for this example I will enter 54. What this does is actually tells the aircraft that the temperature is higher than it actually is, and the aircraft won't use the full thrust for takeoff. We also have the engine out acceleration altitude, which is usually the same as thrust reduction altitude as entered here. V1, VR and V2 are calculated before that and either given by the dispatch in the load sheets and the performance sheets. So for this departure we'll use a V1 of 134, VR will be 140, rotation speed, and the V2 will be 145. After entering the V1, VR and V2 speeds, we have the calculated speeds for flap retraction, for slabs retraction, and for clean aircraft speed. So this is the minimum speed, so that means that at 140 is the minimum speed that we can start retracting the flaps. On it one we can start retracting the slats, and at 200 the aircraft should be or could be clean already.
Well, that's it. You now know all the basic and essential steps for free flight phase completion on the MCDU. Of course, there's a lot more to learn, and so we'll teach you. Just stay tuned for more upcoming videos. Bye!